All right, let's jump into today's deep dive. It's kind of amazing, isn't it, how good large language models, LLMs, have. I mean, they understand really complex text, they can summarize things, even write creative stuff. Just phenomenal with language.
Absolutely phenomenal. Their grasp of context and generating human-like text is incredible.
But here's the twist, and it's a surprising one. These super smart models often, well, they often mess up on things that seem simple, like basic math problems. It's almost like they're, brilliant poets who can't quite balance a checkbook.
Yeah, that's a good way to put it. It's a real paradox.
And that's exactly the challenge we're digging into today. Our mission is to unpack this thing called CodeSteer. It's a new smart coach system from MIT researchers, Professor Chuchu Fan and Yangkao Chen, a grad student.
Right.
We want to figure out how it works, how it helps these LLMs switch between like thinking in words and thinking in code, and how much difference it actually makes for accuracy, and what this means bigger picture for AI problem solving down the road. And just so you know, all this comes from some fresh research out of MIT News, published literally today, July 17th, 2025. So where should we start with this text versus numbers problem?
Well, I think you have to start with just how good LLMs are at the text part. Their strength really is in understanding context, pulling logical answers from documents, seeing the nuances. I mean, that's their core intelligence. It felt like sci-fi just a few years back.
Totally. You see them extracting insights, inferring meaning. It's genuinely impressive stuff, but then, like you said, ask them something simple with numbers.
Exactly, that's the gap. That's what CodeSteer is trying to fix. They often get basic math wrong. The research gives a great example. Ask an LLM, which is bigger, 9.11 or 9.9,
Okay.
relying just on its text brain, it often gets it wrong. Because, 11 looks bigger than 9, textually speaking.
Ah, right. It's not thinking computationally.
Precisely. Textual reasoning just isn't built for that kind of precision. And yeah, some LMs can generate code, maybe some Python script or something.
Right, they can write code.
But they don't always know when that's the right tool to pull out, or even what kind of code is best. It's like having a calculator but not knowing when to use it instead of just guessing. It's a mismatch.
Okay, so the LLM is like this brilliant student, maybe great at essays, but needs a math tutor. And that tutor is CodeSteer, this smart assistant from MIT. So what is it exactly?
So CodeSteer itself is actually another LLM, but a smaller, more lightweight one. Its whole job is basically to guide the bigger LLM, to help it decide, okay, should I use text here or should I generate some code?
So it's not doing the heavy lifting itself?
No, not really. Think of it more like a coach or a trainer. That's the core idea. It's providing strategic advice to the main powerful LLM. It enhances what's already there.
A coach. Okay.
Yeah. Yangkao Chen, the student on a project, used this really helpful analogy. He said, in sports, a trainer may not be better than the star athlete on the team, but the trainer can still give helpful suggestions to guide the athlete.
Right. Makes sense.
This steering method works for LLMs too. And what's really clever about this is that you're just fine-tuning this smaller coach model. You don't risk messing up all the amazing things the big LLM can already do. You get the guidance without disrupting the core strengths.
That's a great analogy. It clarifies that it's about strategy, not raw ability, teaching the star athlete when to pass versus shoot, maybe. But does this imply like a fundamental weakness in the big LLMs?
Yeah.
That they need this external help? Or is this just the smartest way to get this hybrid text code skill?
That's a really sharp question. I think it does point to how current LLMs are built. They're amazing pattern matchers, fantastic language generators, but they aren't, inherently designed for that strict step-by-step computational logic like a traditional program is. So yeah, you could say it highlights a current limitation for those specific tasks. CodeSteer acts like an intelligent layer on top. It lets the LLM use its text skills to write the code and then helps it use that code effectively, all without having to fundamentally rebuild the LLM's brain, so to speak. It's probably a much more efficient way to add that skill.
Fascinating. So let's get into the nitty-gritty. How does this coaching session actually play out? How does CodeSteer, whisper in the big LLM's ear about whether to use code or text?
Right, so it's this back and forth process. It's iterative. First, CodeSteer looks at the question, the initial query.
Okay.
It then decides, okay, is this a text problem or do we need code? And if it's code, what kind of code? Like simple math, maybe a Python script, or something more complex, like needing a search algorithm.
It makes that call first.
Yes. Then, based on that decision, it creates prompts for the big LLM. Instructions, basically, on the approach to take. The big LLM follows the prompt, generates an answer, and sends it back to CodeSteer.
And CodeSteer checks his homework.
Pretty much. If CodeSteer looks at the answer and says, nope, that's not right, it doesn't stop there. It keeps prompting. It might suggest, okay, try refining the code this way, or maybe you need to add this constraint, or think about using a search algorithm here. It keeps pushing, iterating until the answer is correct.
Persistent coach.
Exactly.
Huh.
Chen even mentioned this lazy LLM idea. Sometimes the big models try to take shortcuts, use shorter, maybe less effective code.
Huh, really? Lazy.
Yeah, well, maybe efficient in their own way, but not always robust. CodeSteer is designed to nudge them away from that to generate better, more solid code. And it has these built-in checks, too. One's called a symbolic checker, looks at the code itself, its complexity, efficiency. And another is self-answer checker. So really, it actually prompts the LLM to generate more code just to verify its own first answer.
Wow. Okay. So it forces the LLM to double-check its work using its own tools.
Exactly. A pretty comprehensive coaching system. It's constantly pushing for the best, most accurate, and efficient solution.
That is incredibly clever. Building in self-correction like that, this sounds really powerful, but
Yeah.
I mean, were there hiccups? Did it always work as planned? And what was the biggest surprise when they saw the results?
That's a fair question. Research rarely goes perfectly smoothly. I think the main challenge they mentioned was really figuring out the best way for CodeSteer to prompt the main LLM. Getting those instructions just right so they're consistently helpful, that's tricky. It's a fine art.
Right.
But the biggest surprise, definitely the scale of the improvement. It wasn't just a little better, it was dramatically better.
Okay, tell me about the numbers.
So CodeSteer boosted accuracy on what they call symbolic tasks, things like multiplying big numbers, logic puzzles like Sudoku, even planning how to stack blocks correctly by more than 30%.
30%. That's huge for these kinds of tasks.
It really is. And what's maybe even more striking, it allowed less advanced LLMs, when coached by CodeSteer, to actually beat more powerful state-of-the-art models that supposedly had better reasoning skills built in.
Whoa. Okay, so the coaching makes a massive difference.
A massive difference.
Yeah.
In their tests, CodeSteer blew past all 9 other methods they compared it against. Average accuracy jumped from around 53% up to over 86%.
53 to 86? That's transformative.
Absolutely. And it wasn't just on problems it had seen before. It worked almost as well on new unseen tasks and across different types of LLMs too. So it seems pretty robust. It generalizes well.
That implies something really important, doesn't it? That maybe we don't need to just keep building bigger and bigger, more expensive models for every single problem.
That's a key takeaway, I think.
So what about the real world? Where can we actually use this? Where does this coaching make a difference beyond lab tests and benchmarks?
Right, connecting it to the real world is crucial. This could be a really big deal for complex problems where just talking about it, the textual reasoning isn't enough. Think about planning the best path for a robot that's moving through a place with lots of unknowns.
Okay, yeah, robotics.
Or figuring out the most efficient way to schedule shipments for a global supply chain. Tons of variables, constraints, stuff that needs hard logic and calculation.
Things where getting the math wrong is costly.
Exactly. Professor Fan's bigger vision here is really interesting. It's less about building one giant AI brain that knows everything, and more about enabling AIs to intelligently pick and use the right tools for the task at hand. Like a human expert would use different software or methods.
A toolbox approach.
Sort of, yeah. Intelligent tool use. And they actually had to build their own set of test problems, this thing called SimBench. It has 37 complex tasks, spatial reasoning, math, logic, optimization, because the existing tests just weren't challenging enough to really push this kind of smart switching between text and code.
So CodeSteer isn't just some clever trick. It feels like it could be part of a bigger shift in how we think about building AI. Not just one model, but maybe systems of models, specialized roles. What does this mean for the field overall?
I think it taps right into what researchers are calling a critical challenge, which is tool utilization in LLMs. How do we get these models to effectively use external tools, including their own code generation?
Right.
Jin-Sung Yoon from Google Cloud AI, who wasn't involved in this specific research, apparently called CodeSteer an elegant solution and a substantial contribution. It gets around trying to make one model a jack of all trades, and instead focuses on smart specialization and delegation.
Delegation, I like that.
And Chi Wang over at Google DeepMind, also not involved, saw it as pointing towards intelligent collaboration among diverse AI agents. different AIs working together, maybe with coaches like CodeSteer guiding the process, that could lead to much more robust and versatile AI
Yeah,
systems.
collaboration between AIs. That's a cool concept.
It really is. It suggests a different architecture for intelligence.
So what's next for the MIT team? Where do they take CodeSteer from here?
Well, two main things they mentioned. First, they want to make CodeSteer faster. That back and forth prompting takes time, so they want to streamline it to make it more efficient, especially for real-time uses.
Makes sense.
And the second thing is really ambitious. They're looking into how you could fine-tune a single model to have this switching ability built in. So instead of a separate coach, the main LLM would just know internally when to shift from text thinking to code thinking and back again.
Wow. Integrated coaching.
Exactly. Like it becomes part of its own thought process. That would be a huge step.
Yeah, it really would be a game changer. Okay, so let's just recap quickly. CodeSteer is essentially this smart coach, a smaller LLM that guides a bigger one, teaching it when to reason with text and when to generate and use code. And this makes the bigger LLM way more accurate and versatile for tasks needing logic or math. It's about specialized guidance.
That's a great summary. It highlights the power of adding that strategic layer.
So here's something to chew on, a final thought for you listening. How might this whole idea moving away from chasing one single super AI towards building these collaborative systems with specialized coaches guiding generalist models, how might that fundamentally change our whole approach to building artificial intelligence and what we expect it to be able to do in the future? It really reimagines what integrated AI might look like,